You know that feeling when you look at a scientific chart and your brain just shuts down? Well, we're going to change that today. We're going to pull back the curtain on these charts and show you how to read the amazing stories hidden inside all that data.
So here's the deal. I've got a challenge for you. Can we crack these scientific charts together? Don't worry, I'll be your guide, and I promise by the end of this, you'll be reading these things like a pro.
Our source material for today is a science quiz that's all about our planet. But it's not your typical quiz. It's packed with all kinds of charts and diagrams, and we're going to use them to learn how to read the stories that data can tell.
Okay, first up is a really big topic, ocean acidification. It sounds complicated, but what's actually going on in our oceans? Well, let's let the data do the talking.
All right, let's break down this first question. On the left, we have the pH scale. This is our cheat sheet. The most important rule to remember is lower numbers mean more acidic. Got it? Okay. Now look at the graph on the right. See that line? It's clearly trending down, right? That's showing what's happened to the ocean's pH for more than 60 years. So, what does a decreasing pH actually mean?
It means our oceans are becoming more acidic. And boom, just like that, you've read your first scientific chart. A simple line going down on a graph tells a massive story about our planet. Okay, so we know the oceans are getting more acidic. The big question is, why? What's the culprit here? Well, the next chart gives us the answer. This is a classic before and after story, but it's told with arrows. On the left, you've got the past. On the right, a projection for the future. The key here is to look at the thickness of the arrows. Notice that CO2 arrow? In the future model, it gets way thicker. That means a lot more CO2 is entering the ocean. But then, look what happens to the arrow for carbonate ions. It gets thinner. It's shrinking. So yeah, it's really all about the arrows. Thicker means more, thinner means less. Super simple. More CO2 is going in, and as a result, fewer carbonate ions are available. And that right there is the answer to question 2 laid out plain and simple. So why do we even care about these carbonate ions? Well, think of them as the essential building blocks for creatures like shellfish and corals. They need these ions to build their shells and skeletons. So fewer building blocks means weaker shells, which is a huge problem for a ton of marine life. And that's the core of question 3.
So we've identified a serious problem. But here's the good news. Scientists are already working on potential solutions. Let's check one out.
It's a process called coastal carbon capture. And it has a secret ingredient, a green volcanic mineral called olivine. The whole idea is to use this natural mineral to fight back against that rising ocean acidity.
So how does it work? Well, the process itself is surprisingly simple. First, you mine the olivine, then you grind it up into sand, and then you just spread it on coastlines. But here's where the magic happens. Once it's in the water, the olivine basically acts like a sponge, soaking up the hydrogen ions that make the water acidic. And when you take those ions out of the equation, the water becomes less acidic. It actually raises the ocean's pH. So remember that downward trend we saw in the very first chart? This process could actually help reverse it. And there's your answer for question 4. Olivine helps heal the ocean by raising its pH.
Okay, deep breaths, everyone. It's time for what I like to call the final boss of scientific charts, the ternary graph. I know, it looks incredibly intimidating with its 3 different axes all pointing in different directions. But trust me, we're going to break it down and it's not as scary as it looks.
So what is this thing even for? It's for showing the mix of 3 things that always add up to 100%. Think of it like a recipe for a smoothie. You've got 3 ingredients, say clay, silt, and sand. And this chart can show you the exact percentage of each ingredient for any point on the chart. The trick is to just look at one ingredient at a time. Let's start with clay. See the lines that go straight across, horizontally? That's the clay axis. At the very bottom, it's 0% clay. As you move your finger up toward the top point, the percentage of clay goes up, all the way to 100%. Simple enough, right? Okay, 1 down, 2 to go. Now let's look at silt. Its lines run diagonally down and to the left. If you're on the far left edge, that's 0% silt. As you follow those lines toward the bottom right corner, the silt percentage climbs all the way up to 100. And last but not least, sand. You've probably guessed it. Its lines run in the other diagonal direction, down and to the right. So the far right edge is 0% sand, and as you move toward that bottom left corner, you get more and more sand, until you hit 100%.
All right, let's put it all together and solve this puzzle. The quiz is asking us to find the spot that is 50% clay, 30% silt, and 20% sand. Okay, So first, let's find that 50% clay line. Got it. Now let's trace down the 30% silt line. Yep, there it is. And finally, the 20% sand line. And what do you know? They all cross at one single spot, point B. We cracked the code.
And that's the absolute beauty of this. You now have the key to unlock any point on this chart. For that next question about finding the composition of point D, you just do the exact same thing. You've totally got this now.
So let's just pause for a second and appreciate what we just accomplished. We didn't just answer a few quiz questions. We've actually unlocked a whole new set of skills for understanding the world around us.
You've built yourself a seriously powerful new toolkit today. You can read pH graphs, you can analyze diagrams with arrows, and you can even take on the mighty ternary graph. That is a huge win.
So, I'll leave you with this challenge. The world is absolutely filled with data, filled with stories that are just waiting to be read. Now that you have the tools, what stories will you discover? Get out there and start exploring.